Okay, do y'all remember anything about matrices from last year in Algebra 2? No, not really. Yeah, it's been a while. A matrix is a rectangular array of numbers. They use matrices to display large amounts of data that you can quickly manipulate. And so we're going to look at how you add, subtract, multiply matrices today, how you solve systems of equations with matrices, and then we're going to look at solving matrix equations. So your 8.1 assignment is all about solving systems of equations using matrices. I'm going to show you how to do that by hand, and we're going to look at how you use a calculator on the website. Usually I show you how to use graphing calculators for that, but since the majority of us are not here, I can show those of you in class that have yours how to use your calculator for matrices if you want me to in a little bit. But otherwise, I'm going to show you a website that you can quickly type them in and get your answer. So when I make you do it by hand, you're not going to like me so much, but when I let you use a calculator, you're going to love that because it's just typing in a few numbers, click, get your answer. All right, matrices are named by capital letters. So I've given you one out to the side as an example, A. The numbers inside are called elements. Some of your math lab problems in 8.3 are going to ask you, what is A sub, and they might ask you, like, what is A sub 3, 1? They want you to give the element that is in row 3, column 1. So that's what these numbers stand for. Row 3, column 1. What number is in row 3? There's not even a, yeah, there is. Row 3, column 1. Negative 3.
Good morning, Grayson High School. Please rise for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now for the announcement. Voting for homecoming queen has been extended to Friday. There is a HOSA meeting today via Zoom at 11:50 to 12:15. Come vote for a t-shirt and sign up for competitive events. Have a great day, Griswold.
Okay. So this first number is just simply where the row it's at. The second number is the column. So row 3, column 1, negative 3. Okay, next thing about a matrix is it has what's called an order or dimension. And you always give that as row by column. So matrix A, it's got 3 rows, 2 columns, so we would say that's a 3 by 2. You're going to use the order or dimension to help you determine if you can add and subtract them, or if you can, you're going to use that also to tell whether you can multiply. Okay, equal matrices that's just simply matrices that look like they're squares. They have the same number of rows and columns. Okay, so to add and subtract, your matrices have to have the same order. So I can't, like if I was wanting to add another matrix to A, it would also have to be a 3 by 2 To multiply, you only look at the inner numbers of your order. So let's say I've got a 2 by 3 matrix and I want to see if I can multiply it to a 3 by 2. You simply compare your inner numbers, and if they're the same, you can multiply those. If you check their dimensions and these inner numbers do not match up, the number of columns in the first one is not equal to the number of rows in the second, then they cannot multiply. So you would say cannot do, or it's undefined. So adding and subtracting, it has to have same number of rows, same number of columns in both. And then multiply, you check your inner numbers. Number of columns in the first has to equal the number of rows in the second one. Do you remember hearing that last year? No? No. All right, what we're looking at today, and I've already told you this, you don't have to write this part down, but we're going to look at adding and subtracting them, multiplying matrices, solving systems of equations. That's what we're going to start with, since that was 8.1. And then finally, the last thing in 8.3 is solving matrix equations. All right, in order to solve a system of equations using matrices, let's say I've got this system of equations, for example. Last year, if you remember doing that in chapter 3 in algebra 2, it was awful doing it by hand using substitution or elimination. It took forever, it took a whole page at least. But you're gonna like being able to use this method. What you need to make sure though, in all of your problems in MATLAB, you need to make sure that all of your variables are on one side and all of your constants or numbers are on the other side. And so if you check, all the X, Y, and Z's are on the left side, all the constants are on the other side. Then your second step, how you use a matrix, is you write this system into what we call an augmented matrix. And the way that you do that is you simply take all of your coefficients of your variables and what your equation's equal to. What the equation's set equal to will go on the right side of that bar. And so if I list all of my coefficients across the row for this first equation, you have 3, 1, and 2. Are y'all okay with that? So I've got 3, 1, 2, and I write that here, and then I write whatever that equation is equal to the right side of that bar. If you are missing any variables, like let's say this second equation didn't have a y, then I would put a 0 for that variable. And make sure you line them up. Like for example, if I start out listing 3, which is associated with x, then on down that same column, I have to make sure I put all the numbers with the x's in those spots. Does that make sense? Okay, tell me what row of numbers is in the second row. 1, 1, and 2. Good. And then of course 19. And what about the bottom row? 1, 3, 2. Okay, so that's the first step. Then how you actually solve this by hand, which is what we're about to go through, gets very long and tedious. The math involved in it is not very hard. You're just adding, subtracting, multiplying, but it's just very long. So what your goal is to solve this system of equations in matrix form, you want this matrix to have ones along your diagonal from top left to bottom right, and you want zeros to be everywhere else. And whatever numbers end up in those spots are your X, Y, and Z. Getting all of these numbers to transform to ones and zeros, we use what's called Gaussian elimination, or you may also hear it as Gauss-Jordan elimination. So using Gauss-Jordan elimination, you use what's called row operations, where we can add, subtract rows to one another. Do you remember solving systems using elimination last year when you multiplied an equation by something and added it to get things to eliminate? That's kind of what we're doing. You don't have to write this down, but you can. You can add, subtract rows to each other. You can also switch rows. When you get your matrix to look like this is called reduced row echelon form. On your calculator, you're going to see, like if you go to your matrix area in your calculator, you will see an RR. You don't have to know this either. RREF form, unless you want me to show you on the calculator later. Okay, so what our goal is, we would want to start in this first column, and you would want to make this number become 1 and these numbers become 0. And then you would move on to your second column and make the middle number become 1, which it already is, and then make these two numbers 0, and then move on to the last column and so on. All right, so let's do one by hand, and then I'll show you how to use the calculator online to solve it. I think your directions in MATLAB say use Gaussian elimination or use Gauss-Jordan to solve. So this is what we're given in this system: negative x plus 2z equals 5. 3x plus y minus z equals negative 7. Sorry, I was writing sideways. Okay, our first step, let's write it in what? What did we call that matrix? What type of matrix? Augmented? Okay, tell me what is missing in this first row. A y. So you're going to have negative 1 and then 0 where y would be, positive 2, and then 5. What is your second row of numbers? And third row? I can't count. Whoop, yep, it should have been 0, 4, and 0, 4, and 1, and negative 6. Okay, so once again, you want these numbers down this column to become what? Numbers down this column have to become 1, 0, 0. The numbers down this column, we want to be 0, 1, 0, and then 0, 0, 1 to solve it. And the numbers we end up with here will be your X, Y, Z. All right, so let's focus on this first column. I want this top number to become positive 1. So tell me what you could multiply, add, subtract, whatever. How could you make this become positive 1? Good. So what you're going to do, this is how you keep up with it throughout the whole process. You're going to multiply row 1 by negative 1. And each time you do a row operation, you write your new matrix. So that's why it takes forever. Tell me which 2 rows stay the same. The second and the third row, right? We're not doing anything to those yet. The only thing I'm doing, I'm taking row 1 and multiplying it by negative 1. So these numbers become 1, 0, negative 2, and negative 5. Are y'all okay with that so far? Okay. We're in luck here because this number is already 0, and that's what you want. But we somehow got to get 3 to become 0. Notice since this is 0, I can't multiply this by anything and add it to this row because 0 times anything is 0. So then I have to look at using row 1. Tell me what would this number have to be to add it to this to get 0? Good. So we're going to multiply row 1 by negative 3, and then you're going to add it to row 2 to get your new row 2. So once again, I'm multiplying this by negative 3, and I'm going to add it to all these numbers to get my new row 2. You have to be really careful here. Even though we're multiplying row 1 by negative 3, row 1 does not change. The only row that changes is the one you're adding to, if that makes sense. So I'm going to bring over row 1, which is 1, 0, negative 2, negative 5. And I'm going to bring that third row down as well. Okay, so this is the part that you need to be able to do in your head, or else you're going to have to go out to the side and do extra work. So we're going to do, or multiply every one of these numbers by negative 3 and add it to the second row. So 1 times negative 3 is going to give us negative 3 plus 3 is 0. 0 times negative 3, of course, is 0 plus 1. And then negative 2 times negative 3 is 6 plus negative 1 is 5. Negative 5 times negative 3, 15 minus 7 is 8. So even though you write this, you're doing this part to the previous matrix to get your new row and new matrix. Okay, so we have 1, 0, 0 down this column. So now let's move on to the second column. Look, what is the only number in the second column you need to change? Good. But since I want to make it 0, you can't, I know some people in the past wanted to go through and multiply a whole row by 0, and you can't do that. You have to use this row that contains 1 in a very similar manner to what we just did. So what can I multiply row 2 by and add it to this row to get this 0? -4. So multiply -4 to row 2, and we're going to add it to row 3. What are the 2 rows that don't change? Good, yeah, top 2. All right, are y'all okay so far? Okay, once again, we're going to do this in our head with the previous matrix before it. So go multiply all these numbers by -4. Of course, this one's going to stay. -4 times 1, -4 plus 4 gives you 0. -4 times 5 is -20, plus 1, -19. -4 times 8 is -32, minus 6 more is -38. So now we have that second column as 0, 1, 0. So now we move on to the third column. Once we get this third column converted to 0, 0, 1, the numbers here will be our answer finally. Okay, in that third column, what number do we focus on changing first? Be careful. We want these numbers to be what? 0. So let's focus on making this number 1. Always change the 1 first and then move on to your other 2. So this is, oh my God, this is gonna be fun. Okay, how can you make -19 becomes 1? You can multiply. Okay, I'm glad you said that. If I go through and I multiply this row by 4, you will get +20. What will you get here? Right, you will get, well, it doesn't matter. That doesn't matter though. If I multiply a row to add it to something, that doesn't matter. But you'll get 4 here, but when you add it, this will turn into 4. So that's, if you're going through and changing number to 1, just multiply by its reciprocal. So 1, we're going to multiply row 3 times -1/19. So that's why I said, right, this is gross. It should work out okay in the end. We'll see. Sometimes you do wind up with fractions. Okay, so bring over row 1 and row 2. -19 times -1/19 will give us +1. Oh, that does work out nice, thank goodness. Okay, what is -1/19 times -38? 2. So that, I thought we might have fractions there, but we didn't. Okay, now what can you, and it doesn't matter, you can choose to work with row 2 or row 1, doesn't matter. What could you multiply row 3 by and add it to get -2 to become 0? There you go. So 2 times row 3 plus row 1, and we're almost done. We're getting there. So 2 times row 3 plus row 1. So row 2 and row 3 stay. I'm multiplying 2 to 0 in both cases, so these numbers up top will stay the same. And then that will give me 0. And then 2 times 2, 4 plus -5, I'm going to get -1. So now that we've got that first row taken care of, what's the value of x? -1. Okay, last but not least, multiply row 3 by what? -5, because we want this to become 0. So this needs to be -5. So row 3 stays, row 1 stays. And when you go through and multiply this by -5, those stay, and then you get 0 here. -2 times -5 is -10. And then add 8, so you get -2. Okay, so how you know which one is X, Y, and Z? Remember, these numbers down the column were all coefficients of what? X. And so the only place where you have 1 and not 0 is here. So then you look across, and that number is X. And once again, these numbers down the column we wrote as our Y's. The only place you see 1 is here. So look across, Y is -2 and Z is 2. So that's a lot of work solving it by hand. A lot. All right, let me jump out real quick and show you this link. I've got it written here as well on the board, but it's posted in your Schoology. And you simply go and type in like all your coefficients. So we're going to type in like -1, then we had 0 and 2. And we didn't have a fourth term, but we did, it's set equal to 5. And then you had 3, 1, -1, 7, 0, 4. And then all you have to do is notice you've got a solve by Gaussian elimination or Gaussian elimination. Just hit Gaussian elimination and then scroll down. They're getting something different. I mean, I'll talk to the internet. Let me make sure. 3, 1, -7. Okay, so you'll notice they give their answer here, and notice it's -1, -2, and 2, just like we got. Did y'all see what is everybody okay with that? Okay, so you probably like the calculator or online method a lot better than by hand. All right, next thing, let's move on to adding and subtracting. Okay, we said in order to add and subtract matrices, they have to have the same what? They have to have the same interior numbers and the same what? Good. So what's the order or dimension for A and B? 3 by 3, and this is also a 3 by 3. So this is the same order as that, so we can add and subtract them. In the first part, we're going to find out what B minus A is, and then we've got another part B, and then we'll move on to multiply. Okay, so adding and subtracting is as easy as it's always been for you. All you're going to do is subtract corresponding elements, but be careful what order it's in. Notice they start with they start with B and then subtract A. So you need to start with all of these numbers in B. Then you're going to say 6 minus what? And you can also write it again if you want to, but I usually don't and try to do it in my head to save time, but it may help some of you. So if you write matrix B first and then matrix A, you're going to subtract corresponding elements. So I'm going to say 6 minus what number? 2, and that's going to give me 4 in my new matrix. And then you've got 10 minus negative 10, which turns into what? 20. And negative 2 minus negative 2 turns into 0. And then 0 minus 14, negative 14, negative 12 minus 12 is negative 24. You get negative 14. What are my bottom 3 numbers here on that last row? Yep, negative 9, 0, and 0. Okay, how do y'all feel about subtracting and adding matrices? Good with that? Okay, the last part of adding and subtracting, they may do what's called scalar multiplication, where you're going to multiply 3 to what? Like if I say 3 times matrix A, then you're going to go through and multiply all these numbers by 3. So 3A, tell me what your new row of numbers becomes here. Okay. All right, is everybody okay with that? Okay, and then I'm going to also multiply all of these numbers by 3. That's going to give me 42, 36, 30. And then that last row multiplied by 3, 12, negative 6, negative positive 6, and positive 6. Okay, so that's 3A, and then I'm going to add it to 2B, whatever I get when I multiply B by 2. So once again, go through and multiply every element in B by 2. You're going to get 12, 20, negative 4, Okay, so when you see a problem like this, follow your order of operations as you normally would, multiply before you add. So now that I've found out what 3A and 2B are, I can finally add corresponding elements. So this first row of numbers will be what? 18, -10, -10. -30 plus 20, -6 plus -4. And then the third row, you get 42, 12, 22, and 2, -10, and +2. Okay, well, I went through that kind of fast. Are y'all okay with that? Okay. Okay, in this particular problem, you're asked to find E plus F times D. So once again, follow your order of operations when you get to a problem like this. All right, what's the first thing you're gonna find in this case? E plus F, and once again, just add corresponding elements. So you get -1, and when you add those, that gives you -2. Add those, give you 4, and last but not least, add the remaining. So E plus F gives you this matrix, which is a 2 by 2, and in order to see if it will multiply to D, we have to check these dimensions. So it's got 2 rows, 3 columns. Those inner numbers do match up, so they will multiply. Okay, do you guys remember the song from last year? That row by column song? No? Just say yeah or no. I was gonna say, I know I played it for mine, and I think, and Miss Rogers is the one who showed me, and she loves that song. So, all right. So when you're multiplying matrices, be very, very careful. You have to do it row to column or row by column. So what that means is you're going to take this row of numbers and you're going to multiply it to all 3 columns. Tell me what's your, okay, I didn't mention this, but when you're multiplying matrices, 2 by 2, 2 by 3, the inner numbers tell you that they can multiply. The outer numbers give the dimensions of your answer. So when you multiply these, your new matrix should be a 2 by 3. So we'll see if that happens. Okay, this is what I do that always helps me. I've got this row and I've got 3 columns. So I'm going to write that row of numbers, -1 times something plus -2 times something. since I have 3 columns, I'm going to write that 3 times. Or you could, of course, write -1 times something and then -2. And we'll do the same thing with that other. So we've got this row of numbers, and I'm going to write it 4. That just helps me if I go ahead and write the row out like this, however many times I have columns in the second matrix. And then I can go back through. I took this row and multiplied it to the first column. So I fill in with 1 and 1.5. Are y'all okay with that? And then 1, 1.5, 1 point, nope. Okay, then this gets the second column numbers, -2, 0.5, and then 5, and -3. And then you took this row, multiplied it to this first column, so those numbers, multiplied it to the second column, so those numbers, and third column. Okay, then just do your math, and you'll have your new matrix. Okay, it's almost time for us to go anyway. All right, I'm gonna save the matrix equations for tomorrow for class B. And so I'll do that with them and then record it and upload it for you guys.